Welcome to the Deep Dive. Today we're looking at a real cosmic mystery, something currently whizzing through our solar system at 60 kilometers per second.
Yeah, that's incredibly fast. Over 219,000 kilometers an hour. We're talking about 3IATLAS, the latest interstellar visitor. It was spotted just back on July 1st, 2025.
Found by the ATLS survey down in Chile. And this object, it's really stirring things up.
It absolutely is. It's forcing astronomers really to grapple with a question that popped up with Oumuamua back in 2017, but maybe even more intensely now.
Which is this thing just a big natural space rock flung out from another star, a really, really big one? Or is it something else?
Something far more unusual, exactly. Is it maybe artificial? The data is anomalous. That's the core issue.
So our mission today is to dive into the research, the observations surrounding 3IATLAS. We got papers arguing its size, its path, its behavior. It all seems statistically, well, weird for a natural object.
Right. We'll unpack those strange details, the things that just don't fit the standard picture, and look at why some scientists are, seriously considering the tech hypothesis again.
Okay, so first things first. Let's define our terms. What exactly is an interstellar object, an ISO?
Fundamentally, it's about speed. An ISO is moving on what's called a hyperbolic trajectory.
Meaning it's going too fast for our sun's gravity to capture it. It's not orbiting, it's just passing through.
Exactly. It comes in from interstellar space, swings by, and heads back out. And believe it or not, we've only confirmed 3 of these so far.
Only 3. Okay, the first one, everyone remembers, right? One Oumuamua in 2017 caused quite a stir.
Oh, absolutely. Initially described as like a cigar shape, super elongated. Though later analysis, looking closely at how the light reflected off it, suggested it might be more like a flat disk, a pancake, essentially.
Right, the pancake object. And it looked like an asteroid, correct? No dust or gas cloud.
That's key. It was asteroidal, no coma, no tail. But here's the kicker. It showed this non-gravitational acceleration.
It sped up as it left the sun, but without any visible reason, like gas venting from a comet.
Precisely. There was no outgassing detected, so the big speculation became, well, maybe the sun's light itself, solar radiation pressure, was pushing on something incredibly thin, like a light sail.
And that persistent weirdness, that lack of a natural explanation for the speed boost, that's why it got a specific classification, right?
Yes. On the Loeb scale, which tries to rank ISOs by potential technological significance, Oumuamua sits at level 4. That means persistent anomalies challenging natural interpretation. Basically, we still don't have a slam dunk natural explanation.
Okay, so that was visitor number 1. Then came number 2, 2I Borisov in 2019. That one was different.
Very different. Borisov was much more straightforward. It looked and acted like a comet.
Had the whole fuzzy coma, the tail.
Exactly. Clearly cometary. The only really unusual thing about Borisov was its composition. It had a really high amount of super volatile carbon monoxide.
Super volatile meaning?
Meaning it turns into gas really easily, even when it's still very far from the sun, much farther out than where water ice starts vaporizing on our own comets.
Ah, okay, so that suggests that it formed somewhere much, much colder than our solar system.
Exactly. A true alien comet. Definitely from another star, but still fundamentally a comet. So on that Loeb scale, it's a solid level 0, consistent with known natural objects.
So we've got the weird accelerating pancake, Oumuamua, and the more predictable, albeit chemically strange, comet, Borisov. Now enter 3IATLAS, and the debate just ignites again.
Instantly. And the first big head-scratcher was its apparent size.
How so?
Well, initially, it just looked incredibly bright in the telescopes. If you assume that brightness was just sunlight reflecting off a solid, rocky surface, the estimates put its diameter somewhere between 20 and 46 kilometers.
Whoa, 20 to 46 kilometers. How does that stack up against the first 2?
It's enormous. If it really was a 20-kilometer solid rock, it would be roughly 1,000,000 times more massive than either Oumuamua or Borisov.
1,000,000 times. Okay, that sounds statistically problematic.
Yeah, it's wildly problematic. That's the size paradox. You see, we think these objects get ejected from other star systems by giant planets, sort of like how Jupiter flings things out of our system.
And there should be way more small things than big things, right?
Exactly. It follows a power law. Small stuff is common, big stuff is rare. So if that process is happening everywhere, and we're seeing something potentially 20 kilometers wide showing up roughly once a decade,
then where are all the millions of smaller ones we should have seen first? Like the Oumuamua-sized ones?
Precisely. Based on the estimated amount of rocky material floating between stars, the odds of seeing something this massive this soon are incredibly low. We seem to be short by a factor of maybe 10,000 in terms of the expected mass reservoir. It just statistically shouldn't be here yet if it's just a random rock.
Okay, so that initial brightness suggested an impossibly large rock. But then the observations got better, and that led to another puzzle, the cometary paradox.
Right. Later observations, particularly with the Hubble Space Telescope around August 2025, they managed to get a better look. And they put an upper limit on the actual solid nucleus size at about 5.6 kilometers or 3.5 miles.
Oh, so much smaller than 46 kilometers. That brings the statistics down a bit.
It does. It suggests that the initial huge brightness wasn't from a giant solid body, but likely from sunlight reflecting off a very large cloud, a cocoon of dust and gas around a smaller nucleus. So, okay, it is showing cometary activity.
But even confirming it's active like a comet didn't solve the mystery.
No, because the way it's active is still really strange. Back in July 2025, Hubble looked closely and it saw no tail trailing behind the object.
Wait, no tail? Isn't that the defining feature of a comet? The sun pushes the dust and gas away.
Usually, yes. Solar radiation pressure and the solar wind push that material away from the sun, creating the tail. But with 3IATLAS, instead of a tail behind it, there was this weird, puzzling glow ahead of it.
Ahead of it, towards the sun.
Yeah, pointing generally towards the sun. We call that an anti-tail, technically, but this seems different, more like a forward-facing glow.
Why would dust and gas be glowing in front of the object?
Well, there are a couple of natural hypotheses being floated. One idea is maybe we're seeing sunlight reflecting off water ice that's only sublimating, turning to gas, right off the very front, the sun-facing side, so it creates this localized bright spot.
Okay, that's one idea. What's the other?
The other, maybe more complex idea involves the dust itself. If this glow is from dusty debris, then that dust must be getting ejected from the nucleus incredibly slowly, like less than 10 meters per second.
And why does slow ejection prevent a tail?
Because if the dust comes off that gently, it basically doesn't have enough initial speed for the sun's pressure to easily push it back into a long classic tail. It just sort of hangs around the nucleus, especially on the sunward side. It makes a fuzzy shroud, not a distinct tail.
Okay, so we have the size issue initially seemed too big, now it's smaller, but wrapped in a huge, weirdly behaving dust cloud with no proper tail, just a forward glow. What else is strange? You mentioned the trajectory.
Yes, the geometry of its approach is, let's say, eyebrow-raising. Its orbital plane, the path it's taking through our solar system, is aligned almost perfectly with the orbital plane of our own planets.
The ecliptic plane, right? The sort of flat disk where Earth and Mars and Jupiter orbit.
Exactly. It's aligned to within about 5 degrees of that plane.
And why is that suspicious for an interstellar visitor?
Because if these things are just randomly ejected from other star systems, their paths should be totally random relative to our system's layout. Think about Oumuamua and Borisov. They came in at really steep angles. Borisov was inclined about 44 degrees, Oumuamua over 120 degrees.
They weren't traveling on the highway with the rest of the planets.
Not at all. They plunged in from way above or below. For 3IATLAS to just happen to arrive almost perfectly flat, aligned with our planet's orbits, the random chance of that is calculated to be maybe 1 in 500.
Okay, so low probability. Anything else notable? Color.
Yeah, one more detail. Spectroscopic data shows it's reddish in color, which is actually similar to Oumuamua.
And what does reddish usually mean for these kinds of objects?
It's often attributed to the presence of complex organic compounds, thermalins, that form on the surface after potentially billions of years of bombardment by cosmic rays out in interstellar space. So that part at least kind of fits the profile of an old, well-traveled object.
Okay, so summarizing the weirdness. Statistically unlikely size mass initially, now a smaller nucleus, but with paradoxical activity, no tail, forward glow, and a suspiciously flat trajectory aligned with our planets. And it's reddish, like Oumuamua.
That's a good summary of the anomalies.
And this isn't just some distant curiosity. You mentioned it's interacting with our neighborhood right now. Where is it going?
That's right, it's making some close passes. It already flew by Mars back on October 3rd, 2025, passed within about 0.19 astronomical units AU. That's less than a fifth of the distance between the Earth and Sun.
Pretty close.
Then it's due to pass Venus on November 3rd, a bit further out at 0.65 AU. Earth gets its closest approach on December 20th, 2025, but it'll be a safe distance, about 1.8 AU.
Further away than Mars, then?
Yes. And then, interestingly, it gets quite close to Jupiter on March 16th, 2026, only 0.36 AU from Jupiter.
It really does seem to be ticking off the planets on its way through. Mars, Venus, Earth, Jupiter.
It's certainly a path that raises eyebrows when combined with the other anomalies.
Which brings us back squarely to that technological hypothesis. How do these anomalies push it towards potentially being not natural?
Well, when you bundle them together, the size statistics, even with the revised nucleus estimate meaning a huge dust cloud, the really weird anti-tail physics, and that very low inclination orbit, it paints a picture that's hard to explain naturally. Just like Oumuamua, this pushes 3IATLAS into that Loeb level 4 category.
Persistent anomalies demanding scrutiny.
Exactly. It forces you to at least consider non-natural origins seriously.
And people are doing more than just considering, right? There's actual modeling being done.
Yes. Researchers have used sophisticated software, tools like Optimum Interplanetary Trajectory Software, or OIT. They've tried to model what kind of non-gravitational forces, what kind of slight pushes or accelerations would be needed for an object to deliberately follow this specific path, hitting these planetary flybys.
And what did they find?
Interestingly, they found that the required acceleration, particularly the component pushing directly away from the sun, the radial component needed for, say, the Jupiter intercept, is positive.
Positive meaning pushing away.
Pushing away from the sun, which means, theoretically, it could be achieved by passive means, like solar radiation pressure acting on a large, thin, reflective surface.
Like the light sail idea proposed for Oumuamua.
Precisely. Doesn't prove anything, of course, but it shows that the observed trajectory isn't physically impossible to achieve with known physics if you assume some kind of engineered structure designed to use sunlight for propulsion.
Okay, so if we even entertain that possibility, the really big question becomes, why? What would the intent be?
Well, that's pure speculation, obviously. Intentions are impossible to know. It could be entirely benign, just robotic exploration, maybe sending probes to sample different environments in our system, data gathering.
Or the less comforting possibilities.
Or you get into more philosophical territory, like the dark forest idea from science fiction, related to the Fermi paradox.
The idea that maybe advanced civilizations stay hidden because they don't know if others out there are predators?
Kind of. And in that scenario, maybe they send quiet probes to check on emerging technological species, like us, to see if we're becoming a potential threat or competitor. Again, total speculation, but it's a thought that arises when you consider technology.
It's definitely the most dramatic possibility. But okay, let's pull back a bit. Occam's razor. Shouldn't we favor the simplest explanation? We only have 3 of these objects identified so far.
And that's the absolutely crucial counterargument. That's the heart of scientific skepticism. You must start with the most probable explanation, which is almost always the natural one.
A natural comet, flung out from another star system.
Exactly. We're in what you might call a low information zone here. With only 3 data points, it's very easy for imagination, or maybe confirmation bias, to fill in the gaps with exotic ideas. Standard astrophysics predicts there should be countless interstellar comets out there, ejected from other systems.
Trillions of them, probably. We just haven't been good enough at spotting them until recently.
Right. And we do have that revised size estimate, now 5.6 kilometers for the nucleus. Still big for an ISO based on previous detections, but not the impossible behemoth initially suggested. It makes the rare but natural comet explanation more plausible.
So maybe it's just a really weird comet behaving in ways we don't fully understand yet.
That's definitely the leading natural explanation. It tells us that maybe our understanding of cometary physics, how dust behaves under solar radiation pressure, especially for objects with potentially unusual compositions or spin states from other systems, needs refining. The anti-tail, the alignment, they're still puzzling, but perhaps not impossible for a natural object, just unusual.
Okay, so whether it's alien tech or just a bizarre giant comet from afar, what's the bottom line? What's the real scientific payoff here?
Oh, the scientific value is enormous, regardless of its origin. The dream goal here, and people are actively studying the feasibility of this right now, is an intercept mission.
Sending a spacecraft to actually meet it.
Yes. To fly alongside it, maybe even collect a sample. Imagine getting just, say, 100 grams of material from 3IATLAS and bringing it back to Earth.
A sample from another solar system.
It would be revolutionary, a genuine time capsule. We could analyze its composition directly, look for isotopic ratios that tell us about its parent star, maybe even look for complex organic molecules, amino acids, the building blocks of life as we know it.
It would be a completely new window into astrobiology, into conditions around other stars.
Absolutely. Instead of just inferring things from light years away through telescopes, we'd have actual physical material from another stellar neighborhood delivered right to our doorstep. That's the incredible opportunity these ISOs represent.
That really is mind-bending. So we're left with this tension. An object that seems statistically and physically anomalous, pushing the boundaries of natural explanations, yet could still just be a very strange comet, offering unprecedented scientific insight.
That's the impasse, yes. Anomalous, but maybe not impossible naturally.
And thinking about these objects, these visitors just passing through, it actually sparks a bigger idea about how planets might form in the first place, doesn't it?
It really does. It connects to this fascinating concept that ISOs, these ejected chunks of rock and ice wandering the galaxy, might not just be debris. They could actually be seeds.
Seeds for new planets. How would that work?
Well, imagine a young star system just forming, a big disk of gas and dust called a protoplanetary disk. Theory suggests there's a tricky stage in planet formation called the meter barrier.
What's that?
It's where dust grains have grown to about pebble or maybe meter size, but they struggle to grow bigger. They tend to drift into the star too fast due to gas drag, or they smash each other apart instead of sticking together. It's a bottleneck.
Okay, so planet formation stalls out at the meter size.
It can be difficult to get past that stage efficiently, but now imagine an interstellar object, maybe a few kilometers wide like 3IATLAS, wanders into that young disk and gets captured by the star's gravity.
Ah, so you're introducing a pre-made large object.
Exactly. You drop a big seed, a planetesimal, right into the mix. That captured ISO, already kilometer-sized, provides a gravitational anchor. Smaller particles and pebbles in the disk now have something substantial to stick to, overcoming that meter barrier much more easily.
So these interstellar travelers could actually be helping to kickstart planet formation all across the galaxy.
It's a theoretical possibility, yes, that these messengers between stars might actually play a crucial role in building the next generation of worlds. It adds a whole new layer to their significance.